Okay, so I'm gonna make you write down the actual definitions, and here they go. So I'm gonna define them in English first, and then I'm gonna tell you what it means in physics. So Merriam-Webster's dictionary defines dispersion, that I'm gonna call fancy D. Oh, I can't draw D's. As the action or process of distributing things or people over a large area. So if you have a group of people that are together, how do you separate them into a larger area? So think of light, white light, as a group of lights together. How do you make them go dispersed out? And deviation, that we define with these deltas, is the action of departing from an established course or accepted standard. So think of this as a deviation away from the normal. So the difference between D and delta. So dispersion historically has been characterized by the three wavelengths we were talking about, called Fraunhofer lines. And why are they called Fraunhofer's lines? Because J. von Fraunhofer studied them. We know that in the sun's atmosphere, the blue and the red gave dark lines because of absorption by hydrogen atoms. Similarly, yellow gave us dark lines because of absorption by sodium atoms. That's how you study how many elements there are in a planet or in a star or on the moon, right? So you look at the light that's coming from them and you see which spectrum the light gets absorbed by, and that's the element that that planet or that star has. So drawing them one more time for ourselves before we do anything else. Okay, so I'm going to draw a prism. I'm going to draw an original line, light coming in. It should have gone here, but it split. And it split. And then all the other colors in the middle. Orange, right? It should have orange. Yellow, right? Green. Green. Blue. And I'm just going to do violet. Oh, that looks actually quite pretty. So this is the important part. This is called the fancy looking B. Dispersion. Dispersion. And this between the original and the yellow is called deviation. And here's our problem. We always measure both of these outside the glass, right? Because we can't necessarily measure them inside the glass. So they have some inherent errors in our measurements. But you know what? That's all we can do. So this is called deviation. So this would be the case when we have a large deviation, but a small dispersion. But we could also have a case where an incoming white light could do this. So red and blue. That's bigger than the other one, right? Not quite. That's better. Do you see that? Where if I was to draw a yellow in the middle somewhere, this one has a very large dispersion. And a smaller deviation. Do you guys notice that? So this type of glass will have a small delta, but a large D. Here's a trick to remembering it. I can put everything together by saying dispersion, calculate for all three wavelengths. And what three were we talking about? Red, yellow, and blue. Why these colors? Because they're the easiest to see, technically. Because our eyes are tuned to what color? Yellow. And then red, we can see the best. And then violet becomes a little bit more difficult, so we just choose blue. We know it's further enough away from red and yellow that we don't have to go all the way down to violet. And then for delta, calculated for yellow. It's how much yellow deviated from the original. I have to give you another formula. A formula that relates dispersion to deviation. So, formula that relates dispersion to deviation. Dispersion over deviation is D over delta, NF minus NC divided by ND minus 1. Where this ratio, you will see in some textbooks, it is called dispersive power. Defined as a delta D over delta. And if you notice, these are the outer lines, and this is the inner line. ND is yellow. So say a question asks you to find the dispersive power of, say, a crown glass, what are you going to do? So you're going to write, for example, delta for a crown glass. NC over NF divided by NB minus 1. So you put in all your values, you solve, and it's done. Similarly, if they ask you to find the delta for, say, a flint glass, you take out your formula, you plug in the numbers, and you're done.